Okay, here's a graph of a function. And at the point of the course where I'm doing this review, or this emphasis on important points, you recognize that as possibly a graph of a polynomial function, but not necessarily a polynomial. How do we represent the value of f of x for a given value of x? Well, what does this mean? The value of f of x for a given x is the value of y for a given x, because y equals f of x. What do you mean by the value of y? Well, let's just pick an x. Let's say that x is here. Okay, the value of y that corresponds to x, well, you take all the points in the plane for which the x-coordinate is this. Well, that would be all the points on this vertical line, because that's where all the points whose x-coordinate is whatever this is occur. And you find the point on the graph that has the same x-coordinate. That would be this point, and the y value is just the y-coordinate of that point, which is the y value. And you don't need this whole line. You could do without the part above and below the axis and just use this little projection line here, and you project over here, and you get the y value. You want to understand the logic of it, though. X values are the same everywhere in this vertical line. You find a point on the curve that has that x-coordinate, and you find its y-coordinate. Okay, that's how you find the value of y for a given x. We can represent the value of f of x by an arrow. Okay, so the arrow represents y, and y equals f of x, so the arrow also represents f of x. Now, let's suppose we wanted to graph to f of x. I'm going to get a little crowded here, but that happens. Okay? Well, 2 f of x means 2 times f of x. And for this particular x, this arrow represents the value of f of x. So 2 of these arrows would represent the value of 2 f of x. So here we have the arrow equal to f of x. So this arrow represents f of x. This arrow represents f of x. So that an arrow with a length equal to both of these represents 2f of x. And if we want to draw a graph of 2f of x, this is going to be a point on that graph. Now, if I want to do the total graph of 2f of x, at least for the part that I see here, I'm going to want to do the same thing for a series of points. Okay? Now, of course, if I choose this point, this value of x, f of x is 0, so of course 2f of x would still be 0. We'd have an arrow of length 0, and we'd have 2 arrows of length 0, head to tail, and we'd still get 0. Okay, so this is a 0. It's a 0 of the function f of x. It's also 0 of the function 2f of x. Now I started using yellow for the 2f of x function, so I'll just kind of draw yellow on top of purple to indicate that's a point on both graphs. Okay, well, let's take a point over here. Okay, for whatever this value of x is, here is an arrow that represents the value of f of x. So if I want the value of 2f of x, I'm going to have to add another vector of the same length, so that now I have a vector representing 2f of x. For this value of x. Now the arrows should be right on top of each other, but you wouldn't be able to see them both. So I've got them offset a little bit, but understand the arrows really are understood to be on top of one another. And then I can do the same thing, and I don't have to label it every time. I can do the same thing for select points. I think that's an important point, because it's kind of a peak. So I get this. And I'm not going to draw the yellow arrow. That's going to get kind of messy. I'm going to do a yellow mark there to show that this point is on the graph. This is, this point up here is, and I select what I consider to be representative points that are going to help me determine the shape of the graph of 2f of x. Okay, so I'll use this point, and I'll use a point here. And that might be sufficient to give us a trend. And of course, I don't want to keep you looking at this forever. Now we also know, again, that any 0 of f of x is going to be a 0 of 2f of x. So I'm going to put yellow marks, yellow x's through all the zeros. Okay? Now I'm just going to connect the points. The yellow points with a smooth curve. Yeah, I got a little carried away there. I should have come up to this point a little closer. The curve's not going to angle over that way, so I kind of messed it up. But I'm going to leave it the way it is. And I'll just say careful. Doesn't really do that. Just keeps getting steeper, so I should have turned around a little quicker. The low point would have been here, and it would have been good if I'd have used that point instead of one close to it. So I just exaggerated a little bit. I stayed low too long. But you get the idea. And you can see that this graph reasonably represents a graph that's stretched by a factor of 2. If you took this white graph and stretched the whole thing by a factor of 2, you would end up with something very much like the yellow graph. Okay. Well, that's called a vertical stretch. Two f of x is f of x vertically stretched by factor 2. There are two other transformations. One is a vertical shift and the other is a horizontal shift. We don't have a scale here, but if now we designate and we say that this is an arrow of length, let's make it a little longer. Okay, I'm going to say that's an arrow of length 3. If I want to vertically shift, let's say, the yellow graph by 3 units, that means I take every point of the yellow graph and raise it that far. So I can do that. I can take representative points, and let's just use some of the yellow points. Well, I don't want to use that one because, well, I'm going to do it anyway. Okay, goes up here, kind of messes up my y equals f of x, but that happens. 3 units above this low point here take me up here. And 3 units above this high point take me up here. And 3 units above what should have been the low point here, going to take me up to about here. 3 units above this 0 is going to be up here. 3 units above this point is going to be up here. So all these vectors are supposed to be the same length, and that length is supposed to represent 3 units. That's going to give me a point here, a point here, a point here, a point down here, a point here, and a point up here. So I can look ahead to where I'm going. Okay, this is going to be my low point, so I'm going to come down to here, and turn around and come up to here. I'm going to have to go down to there. One problem I have is my arm's kind of blocking my view. And then I've got to come on up through here and here. So now the orange graph represents the yellow graph raised 3 units. Now there's another transformation I can do. But what I have for the orange graph is, well, y values have been increased by 3. And we call that a vertical shift. Of 3 units. To the 2f of x graph, and there were no parentheses, so I didn't need to close the parentheses there, did I? Okay. So we started with the white graph, we stretched it, and then we raised it up 3 units. Not difficult to understand. There's one more transformation that we're going to add, and that is we're going to shift each point 3 units. Let's say not 3 units. And let me look at the graph and see what might actually work. I'm going to do a small shift. I'm going to shift each point 1 unit to the right. Okay? Well, that's pretty easy. Let's just take these orange points. Of course, my y equals f of x label's getting all messed up, but let's just take each of the orange points. Each of the points I use in constructing the orange graph, and move it, this arrow, to the right. Then I'm going to have a graph comes up here, down through here, up here, turns around, comes way down here, turns around here, comes up through here and here. That's getting a little messy, but you can see how the points of the green graph are supposed to be exactly 1 unit to the right of the points of the orange graph. And the figure's getting a little messy. The green graph turns out to be the graph of 2f of x minus 1 plus 3. When we shift 1 unit to the right, we replace x by x minus 1, which requires x to be 1 unit greater in order to get the same y value we would have gotten for x before the transformation. That's a little hard to understand, it's a little counterintuitive, but a plus 1 is going to result in a minus 1 on our x value, and of course this is something that we deal with a little bit separately, but this is the picture of transformations. One thing that we notice, of course, if I've done this correctly, if I've done this accurately, all the zeros of the orange graph will move 1 unit to the right to get to the horizontally shifted graph. We call this a horizontal shift, horizontal, vertical. Okay? This is then the 2 f of x graph shifted 1 unit horizontally. Now there's some inaccuracy in the way I sketch these things. Like the 0 here, this should be 0 for the orange graph. It shifted over this far. And this 0 only shifted over this far. Both of these should be 1. And if I'd have drawn the graph more accurately, they would have been. But you get the idea. Okay, and I'm using a polynomial here because it's very easy to see for a polynomial just why the graph shifts to the right if you subtract a number from the x. If you subtract 1 from the x, it's going to shift all the zeros 1 unit to the right, and we talk about that separately.